So what we're going to be talking about in this chapter, now this is chapter 2, so we're going back to chapter 2. We're going to start talking about polynomial functions. And first off, we're going to talk about zeros of polynomial functions. All right, so just a little bit of background on what a polynomial function is. When we say a function is a polynomial function, we're talking about functions where you have the variable, like x, let's say, and then the exponents of the variable are integers, 0 or greater. So for example, x squared, x cubed, okay, x to the 7, these are all, examples of polynomial functions. So for example, f of x is equal to x cubed plus 4x squared minus 2x plus 9. Okay, that's a polynomial function. Something like this, not a polynomial function because it's a root. Okay, absolute value of x, not a polynomial function. Okay, 1 over x, not a polynomial function. So basically it's ones that have exponents that are integers greater than or equal to 0. Okay, now that's a polynomial function. Now let's talk about zeros. All right, a zero of the polynomial function is the x value where the graph crosses the x-axis. So for example, if I have a function that looks like this hits the x-axis in 3 places, so it's got 3 zeros. Now, if this one here, furthest to the right, let's say this was at x equals 7, we would say x equals 7 is one of the zeros. So let's say this is x equals 5, then x equals 5 is the other 0. If this is negative 2, then x equals negative 2 is the other 0. All right, so a 0 is where the polynomial graph hits the x-axis. Now, there are other words for zeros, and those are solution, x-intercept, or root. All right, so when I say find the roots, find the x-intercepts, find the solutions, find the zeros, I'm talking about the same thing. Okay? All right. Evaluating a function at a given point. So to evaluate a function at a given point, there are 2 ways. One is direct substitution, and the other is synthetic substitution.
Whoa.
I know. Synthetic substitution. All right, so direct substitution and synthetic substitution. Let's talk about the first one first. Here's this one. You were given a function, and we're going to use direct substitution to find the desired values. So I have f of x. f of x is 2x squared plus 9x minus 35. I need to find f of 2. So when x equals 2, what is the y value, right? So direct substitution will be, just plug it in, 2 times 2 squared plus 9 times 2 minus 35. This is 2 times 4 plus 18 minus 35. 8 plus 18 minus 35. So f of 2, 8 plus 18 is what? 26 minus 35. 11. Oh, negative 9. I'm so sorry. Oh, okay. All right, so negative 9. So f of 2 is equal to negative 9. All right, so what we did is we just put in 2 for each of the x's. All right, so now let's do the same thing for f of negative 7. This is going to be 2 times negative 7 squared plus 9 times negative 7 minus 35. All right, so you see how I instinctively put parentheses around the number that I'm substituting in? I did it for the 2 as well, right? That's an instinct. It's technically it's a habit that's now become an instinct. It's a good habit to have, because once you've got those negatives and you're multiplying and you're squaring and you're raising it to the power of 3, you've got to put in the parentheses, otherwise you're going to get the wrong sign, right? So this is going to be 2 times positive 49 minus 63 minus 35. So what do you guys think?
0.
Ooh, 0. 0. Okay, so what do we think? What did we do here? We have this function, 2x squared plus 9x minus 35. You graph this. It's going to look, what is it going to look like, by the way? If it's got an x squared, what would it look like?
Oh, it's going to be parabola.
It's going to be a parabola, exactly. It's going to be a parabola. Now, we said that f of 2 is equal to negative 9. That means when x equals 2, right, when x equals 2, y is negative 9. Here. Okay? When x is negative 7, how much is y? 0. Okay? So now, the next question is, are any of these zeros of the function? Right. Because at x equals negative 7, we got 0. That's where the graph would hit the axis. Right? So it says 0 there. So this is, going to look like this. It's going to come down, and then it's going to go back up. Okay? So x equals negative 7 is a 0. Okay? All right, now we're going to do the same thing using synthetic substitution. Okay? So you see how we did here? We had to plug those in, blah, 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 right? That's how we did it. Now we're going to do the same thing, f of 2 and f of negative 7. So what we do here is this. You're looking for f of 2, so I put 2 out here. And I've got a chart. This.
Oh, I like this.
Yeah, I know. I love this. Okay, so now, here's what you have to do. You have to make sure in your polynomial, you've got your exponents lined up from the biggest one down to 0. So here, for example, I have an exponent of 2, 1, and if there is no exponent, it's an exponent of 0. So 2, 1, 0. In decreasing order, we're good to go. Now, what I put in here are the coefficients of these. The coefficients, that's a positive 2, a positive 9. Huh? You put 0 if there is an exponent missing, if it jumps 1. And then here, it's negative 35. Okay, so now here's what happens. Yeah, the 2 comes down for free. Whatever makes it down to that bottom level gets multiplied by the number outside in the blue. Okay, so 2 times 2 gives you 4. You add this way, you get 13. You multiply 26. You add, what do you get? Negative 9. What did we get before? Negative 9. So look here. When we did f of 2, do you see how we got negative 9?
Yeah.
Well, we got negative 9 here. So this tells you f of 2 is equal to negative 9. All right? It's a much, I find that it's a quicker process, right? It's less math. Now, if you forget which way you're supposed to multiply and which way you're supposed to add, the reason why I put my arrows this way is, you see how like I have vertical arrows here? That means like you're adding, it's like a plus, and these diagonal ones, it's a multiplication. Okay? All right, so let's do negative 7 then. Negative 7 will be the number that I put out here. And then inside I have the same coefficients, 2, 9, negative 35. The 2 comes down for free. Whatever makes it down to the bottom row is multiplied by negative 7. So negative 14 plus 9 gives me what?
Negative 5.
Times negative 7, positive 35, and we get 0. So f of negative 7 is 0. Okay? Now, how can we tell if any of these are zeros? Yeah.
The chart ends with a 0.
Right. Normally we would use this to divide, and we used to call that last number the remainder, but just basically say that the last value is 0. Okay, so x equals negative 7 is a 0. Okay? Isn't that cool? So now we know direct substitution and synthetic substitution. On your quiz or test, by the way, the schedule is all on Haiku. It's since last month, so you can go and check. I'm going to ask you for both. So I'm going to ask you explicitly, okay, like find blah, 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 using direct substitution, and find blah, 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 using synthetic substitution. In those questions, I'm actually testing whether or not you know the difference. So you have to do it that way. If you get the right answer with the wrong method, you can't get full credit. However, if I just say, find f of 4, haven't specified a method, it's totally up to you. Okay? My go-to is always synthetic, unless it's like a 1 or something. Okay, or a 0. All right? Okay. So, back to polynomial functions. Did you guys, if you haven't taken Algebra 2, so, all right, so we already talked about polynomial functions. Now, let's go back and recall from Algebra 1 even what the degree of a polynomial is, right? If you have a polynomial like f of x is, let's say, 3x to the 7 plus 4x to the 5 minus 2x cubed plus 9, okay? What is the highest exponent here? 7. The highest exponent is called the degree of the polynomial. So this polynomial has a degree of 7, okay? Highest exponent is the degree. Now, in math, we usually use the symbol n for degree. So if I say a polynomial function of degree n, it means whatever n is, that's the highest exponent. Okay? Now, whatever the highest exponent is, it's magical. A polynomial function has at most that many zeros. So, if a polynomial function has a degree of 7, it can have at most 7 zeros. Okay? What did zeros mean again as far as the graph is concerned? Where it crosses the x-axis. So that one, 3x to the 7, it could potentially hit the x-axis 7 times. Okay? It might happen that it hits it less, but it can never hit it more than 7 times. Now, so the zeros of a function, like when you solve a function and you get the solution, you could have a whole bunch of numbers, okay? You could have rational zeros, or you could have irrational zeros. Okay, so what are examples of rational zeros? Like when you solve an equation and you get an answer, right? What are some numbers that that answer could be? It could be x equals 4. It could be x equals 2 over 7. It could be x equals negative 3 over 5. It could be x equals negative 4, right? All of these are rational numbers. Or it could be x equals root 5, x equals negative root 3, okay? These are irrational numbers. Okay? Now, so suppose I gave you a function like that one over there, right? And I said it could have 7 zeros, okay? And then I said, all right, so try to guess the zeros. Okay, so here's one thing you could do. It's not the wisest thing, but here's one thing you could do. How many numbers are there in the universe? How many rational numbers in the universe? A lot, like an infinite number of them, right? Okay, so one thing you could do is you could take every single number that exists, 0, 1, 2, 3, 1 over 2, 1 over 3, 1 over 4, 2 over 3, 2 over 4, 2 over 5, 2 over 7. Every single number, plug it in here and see if you get equals 0. Because if it equals 0, then you have a solution, right? Okay, that's going to take you your entire life and you still might not solve one problem, okay? Or what you could do is you could say, all right, there could be at most 7 numbers that work. How about if I find a way to narrow it down from all the numbers in the universe to just like a couple, a list, a short list, okay? That's what this rational zero theorem, this P over Q business does, okay? So we're going to narrow down the search for solutions. Okay, so here it is. Here's the rational zero theorem, okay? Look at this polynomial, 2x cubed minus x squared plus 3x plus 4, all right? What we have to do first is we have to find values of p. Okay, values of p are the factors of the constant term, which in this case is 4. So you're always going to have a polynomial function. The last number is always going to be a constant, like without a variable. You have to get the factors of 4. So what are the factors of 4? What numbers can you multiply to get 4?
1, 2,
2 and 2, 1 and 4, right?
Oh, yeah, that's it.
2 times 2, 1 times 4. Okay, but what about negative 2 times negative 2? Yeah? What about negative 1 times negative 4? You could do that as well. So it's not just 1, 2, and 4. It's plus or minus 1, plus or minus 2, plus or minus 4, right? So basically just find the factors like you did in like elementary school and put plus or minus in front, okay? It's kind of exciting. My son's learning factors now in the 4th grade, and I'm like, oh my gosh, you're doing real math. Finally. All right, so now we need values of Q, okay? And for that, we need to find the factors of 2. All right, it has to be the coefficient of the term with the highest exponent. We call it the leading coefficient, okay? So number with term of highest exponent.
Isn't that also the degree?
The degree is 3. We need the coefficient, which is 2.
Oh.
Okay?
Why are we finding the factors of the constant 4?
That's what this rational zero theorem.
So always 4?
It's always the constant term, like the one without the variable.
Oh.
So the last term will give you values for P. The first number will give you values for Q. So the factors for 2 are 1 and 2, but we just put plus or minus 1, plus or minus 2. Okay, now we have to divide each of the values of P by each of the values of Q. So here's how I do this. I take the first of the P's and the first of the Q. Oh, look, I copied and pasted. This should say Q. Okay? So the first of the P's and the first of the Q's. And I do 1 over 1. All right? Now I do 1 over 2. Right? P over Q. So it's going to be 1 over 1. 1 over 2. And then I take this one, 2. And I do 2 over 1. 2 over 2.
Are these plus minus?
Yeah, we're going to put the plus minus in a little bit. Okay?
Wait.
Okay, so what we're doing is we're taking each of those p's and we're going to divide it by the q's. All right, so why don't we ignore this for a minute and work this way? All right, so let me color code it again. I'm going to take the 1 here with the green and divide it by this one, so I get 1 over 1, right? Okay, then I take the 1 and divide it by this, so it's 1 over 2. Okay, now I move on to the next one, 2. It's going to be 2 over 1, 2 over 2. Okay, now I take the next one, 4. 4 over 1, 4 over 2. Okay, so basically it's like you're matching everybody in team P with everybody in team Q. It's like a bracket, right? Everybody in league P has to play everybody in league Q. You just have to match them up with all the different pairings. Okay, now 1 over 1, it's silly to write it as 1 over 1. Why don't we just say 1? 1 over 2 is 1/2. 2 over 1 is 2. Okay, what's 2 over 2? 1, but I already have that. I don't want to be redundant. And so you don't put it. And then I have a 4, and 4 over 2 is 2, which I already have. And now what I do is I just put plus or minus in front of them. Okay? So these are all the possible rational zeros. Now, to write it even more concisely, I just say, look, plus or minus, in parentheses, 1, 1/2, 2, 4. Okay, we don't waste lead that way. All right? So remember how I said you could sit there and plug in every single number in the universe and see if you're going to get a 0? Okay, we now narrowed it down to a much smaller list. 1, 1/2, 2, 4, -1, -1/2, -2, -4. So we now have 8 possibilities only. Okay? All right. So why don't I have you guys do this next one? Okay? All right. In this next one, use the rational zero theorem to determine the possible zeros. Okay, so step 1 is everything we did in up there. So, all right, so what's P here? What are the values of P? Plus or minus 1, 2, and 4. And look, even here I use the parentheses. What about Q?
Wait, why is it 1, 2, 4?
All right, so first for P, I need to find the factors of the last number.
Oh, right.
And then the factors of the first coefficient, which is a 1. Right, for Q. So now for P over Q, each of the P's over each of the Q's. So it's going to be plus or minus 1 over 1, 2 over 1, 4. No. You could just skip to plus or minus 1, 2, 4. Yeah. So I'm going to take the first one, which is 1, and do synthetic substitution on it. All right, what are going to be the coefficients here? 1, -3, -2, 4. Okay, so 1 comes down. You multiply, you get 1. You add, you get -2. Multiply, -4. What did that give us? 0. Okay, fantastic. Okay, you stop when you get a 0. Okay, because what does that mean? X equals 1 is a solution. Okay? Yay, x equals 1 is a solution. Huh? Well, how many? It can have up to 3, right? Now we're going to find the rest. Okay, so now here's what we do. You see this x equal, this 1 here? I write that as x minus that number always. Why minus? Because that's the rule. And then this, you guys remember now? This is going to be the set of coefficients for a new polynomial. Okay, now, this polynomial had a degree of 3. When it goes through this process, the degree goes down by 1. So now it's going to have a degree of 2. So it's going to be x squared, x to the 1, and then no x. And these are going to be the coefficients. So it's going to be 1x squared, negative 2x, minus 4. Okay? So it's... Huh? Whose is that? All right. So it's going to be 1x squared minus 2x minus 4. Okay, now, so this is called the depressed polynomial. Okay. Now you have to factor the depressed polynomial or solve it somehow and get the other zeros. All right, so let's just rewrite that here. X minus 1, x squared minus 2x minus 4. Now, we need to solve this. You could either factor it, or if you can't factor it, in this case, it's not possible to factor that one, you have to use the quadratic formula, right? So let's use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. What's the song? Negative b, that's the one. So the thing is, if you don't know the formula, I don't think you could still sing it because you still have to know, know the formula. But it's fun. Okay, so sing it again, but don't mumble this time.
X equals negative b plus or minus square root of b squared minus 4ac all over 2a.
That's the one. So 4 plus 16.
But how do you know what the sub in means?
Oh, sorry. I assumed, okay. So the coefficient here is a. So in this case, it's 1. The coefficient here is b. So in this case, it's negative 2. And this is c, which is negative 4.
So x minus 1 is a minus.
Yeah, x minus 1, we're neglecting that for now. We're just focusing on this. So over the break, a friend of mine asked me, I guess he's going back to college, and he hasn't taken, I shouldn't record this because it's 2 plus or minus root 20 over 2. Okay, 2 plus or minus, what do we do about that root 20, guys?
It's 2 root 5.
It's 2 root 5. Woo! Yeah. Right? 2 root 5. Okay, now this is my favorite thing to do in math. Okay? Check it out. How many terms do we have here? 1, 2, 3. If you can divide all 3 by the same number,
Do it.
then you must do it. If you can't divide all 3 by the same number, then you don't touch it. Well, in this case, we can divide this by 2, this by 2, and that by 2, and we get 1s all around. So this is going to be 1 plus or minus root 5.
That's the end.
That's the end. So finally, my answer is, my answer is x equals 1 from, before, from here, and x equals 1 plus or minus root 5. So how many solutions is that total? 3, because it's 1 plus root 5, 1 minus root 5, so 3 total solutions. All right, so let's do this one very quickly. Okay, I haven't put the steps here for you, so we're going to have to do it all from scratch. All right, so let's find P. P is the factors of 15. So it's plus or minus 1, 3, 5, 15. Awesome. Q is the factors of 2. 1 and 2. Now, P over Q is going to be 1 over 1, which is 1, 1 over 2, 3 over 1, 3 over 2, 5 over 1, 5 over 2, 15 over 1, 15 over 2. And all this with a plus or minus. Okay, so how many numbers are there? Just in the parentheses, there are 8 times 2, 16. So we're going to have to try synthetic division with 16 of these. And then, until we get one that works. There are 3 possible zeros. So, technically, the most you're going to have to try is 13 numbers. 14 numbers. But that's still a lot of numbers.
So you're gonna have to, like, on the test or something, you have to do, like...
Right. Or, yeah.
Yeah, she's gonna teach us.
You need to do the things that each one.
That's the process, yeah. If you're stranded on an island. Well, because the highest exponent is 3 here, that tells you that there are at most 3 zeros. But, that's what you have to do. But, let's do it in a more,
Fun way.
let's do this. Why don't we, Yeah, then you're out of luck. There can be. 2x cubed. All right, we're going to factor this guy. Oh, yeah. I'll fix it. Plus. All right, so it's not 55 but 5 here, so let me fix that. It's xt theta. All right, so I'm going to do zoom 6 because I don't know what my previous window looked like. Okay, so take a look. Look at all those zeros there. All right, now, so let's pick one. I'm thinking -3 here might be a 0, right? It looks like -3 is a 0, but I want to be sure. So this is what I do. Trace. In trace mode, just type in -3, enter. Did I get a 0? I sure did. So -3 works. Right. You just have to show me the work. So let's do -3.
Oh, we do have to show them.
Yeah, just show me. But like before, we would have had to try 1, -1, half, -half, 3, -3 until we get one that works. Okay, so it's going to be 2, -5, -28, and 15. 2, -6, -11, 33, 5, -15, and I got 0. Woohoo. Okay? Now, x minus -3. And here, it's going to be 2x squared minus 11x plus 5. Okay. So now I'm just going to copy that over here. X minus -3 is x plus 3. And then I get 2x squared minus 11x plus 5. And technically, we're going to set that equal to 0 to solve it. Now, is there any way to factor that? I'm thinking there might be. Let's see. Let's do 2x and x. There is always a way. So what if we do 5 and 1? And what if we do minuses here? Right? That does work. All right? So, and we have the x plus 3 here. It's x minus -3. So, from the first parentheses, I get that x equals -3. What about from the second one? 2x minus 1 equals 0. X equals 1/2. X minus 5 equals 0. X equals 5. So those are the 3 solutions.
All you need is 1 to find out 1 0, and then you get all. Wow.
All right, so what I'm gonna do is I'm actually gonna stop here for today. I'll go back. Let me just tell you about the homework. Here, please do up to 27. You'll do 29 and 31 with part 2. I'll try.
Wait, can you? Oh, yeah.
Yeah.